Hello everyone, this is Kyle Mummey, and this is my ENME351 Lab 6 report. So starting off by taking a look at my circuit, it takes 5 volts in from the Arduino and powers the top side rails of the breadboard seen below. This will in turn power the potentiometer and the servo motor. The potentiometer is hooked up by the green wire to analog pin A0, which will take in the 0 to 1023 value output from the potentiometer. This will in turn affect the angle of rotation of the servo motor at any given moment. The yellow wire connects digital pin 9 in series to the servo motor. This will be written high for a given interval of time, which is dictated from that 0 to 1023 ADC value. The higher the value, the longer the period that it is set high for, which will also maximize the angle of rotation. This angle will vary from -90 to 90 degrees, as you will see later in this video. My code now. The ADC value is sent in to analog pin A0 from the potentiometer. The pulse is set in through the yellow wire from digital pin 9 to the motor. And from trial and error, I found that the appropriate motor delay between readings is 15,000 microseconds, which will be reflected in my loop below. In the loop, the potentiometer value is used to determine the appropriate control period for which this digital pin will be set high for. And from trial and error, I found that the control period for this motor varies from 475 to 2500 microseconds. Anything out of this range really won't affect the rotation of the motor. The potentiometer value is then set to the appropriate -90 to 90 degree value for the current orientation of the motor. And this was found by dividing the potentiometer value by 1023 over 180 and subtracting the 90 degrees. And then it will be delayed by the 15,000 microseconds that was specified above to start the new iteration of the loop. All right, so the USB has been inserted and I've opened the serial monitor. The far left column is the ADC value that is being output from the potentiometer. The middle column is the current angle that the servo motor is rotated, and the far right is the appropriate time period for the digital pin to be set high, and that's in microseconds. So looking down at the setup, as you can see, it's set at the 0 degree orientation as is specified on the serial monitor, but I can adjust that. So it can scan the full scale range from -90 to 90, just like that. And this is shown live on the serial monitor for you. And panning back. Yep. So that is my setup. Thank you for watching.